Let's say that I have a right triangle and I've labeled the sides here A, B, and C, C being the hypotenuse. The Pythagorean theorem is a fundamental relationship between these three sides, which states that if I take the square of the measurement of those three sides, they're in this relationship where A squared plus B squared equals C squared. Now, to explain what this means, what I'm going to do is I'll label these three. I'll say that A is 3, B is 4, and C is 5. So what this means is if I was to take this side, which is a 3, and I was to draw a square here, which side, and the sides of that square are 3 by 3, if I was to divide this, if I was to divide this square into equal parts, and it's not looking too equal, but so if the sides are 3, well then the area inside that square, this would be a 9. So this would be 9 inside here. And then if I did the same for the other sides, I would notice that this side here, this one is 9. I'm writing in white on white. This side is 9. This side, which is 4 squared is 16, and this side is 5, and 5 squared is 25. Plugging in these numbers over here, I have A squared, which is 9, plus B squared, which is 16, equals 25. Now, knowing that this relationship exists, what we can use this for is if one of the sides is missing, it works, the Pythagorean theorem works for any right triangle. I can find the length of a missing side if I know the lengths of the other two. So for this one, I just plug in the numbers. So first I'm going to have, it doesn't matter which, I will label this one A, this one B, and this one C. So I have 12 squared plus 5 squared equals C squared. I'll leave that blank for now. 12 squared is 144. 5 squared is 25. And when I add them together, I get 169. Well, we're not done because I need to now, since these are squares, I need to then take the square root of 169. And the square root of 169 is 13. So the length of this side over here is 13, and don't forget your units, so it's 13 meters. Here on this triangle, I have the hypotenuse is given, and one of the other sides, this time it's A is not given. So when I plug in my numbers, I'm going to get a one or more step equation that has to be solved in order to find what the length of A is. I don't know what A is, so I'm just going to put A squared plus, and then B squared is going to be 2.1 squared, and that's going to equal 2.9 squared. So I still don't know what A squared is. And 2.1 squared is 4.41. And 2.9 squared is 8.41. So in order to solve this, you can keep track of things by writing a little roadmap over here. What's happening to A squared is that I am adding 4.41. So to solve this, I would subtract 4.41 from both sides. So I'm going to subtract 4.41 here and on the other side of the equal sign. Once I do this, I have A squared. I have A squared. This is a 0 pair. I bring down the equal sign. And once I subtract here, I get a 4. And then in order to solve this, I just take the square root of both sides of this equation, and I get A equals 2. And this over here would make A equal to 2 meters. That's our final answer. So here we have a triangle where the sides are fractional, and we're missing C. So we'll just plug in the numbers. So we'll call this one A, we'll call this one B, and C is our unknown. So A squared would be 3 nth squared. And then B squared, which is 2/5, would be squared. And then I have to find C, and then finding C squared. So then over here, squaring a fraction, I prefer to personally to work with fractions than decimals, but squaring this, 3 squared is 9, 10 squared is 100. And I'm going to add to that. 2/5 squared is going to be 4/25. And then I want to have common denominators because I have to add them. So I have 9/100 plus, and I'll multiply the top and bottom by 4. So I have 16/25, 16/100. And when I add those together, I just add my numerators. And this is squared. So in order to find C would be equal to the square root of this, which is 25/100. And the square root of that would be 5/10, which would be 1/2. So C over here is 1/2 of an inch. So this problem, we have C, but we're missing B. And while it looks like it's going to be a simple solution, it is going to require us to have a decimal answer. It's not going to work out to a whole number. And in this case, let's say that you were taking a test and they said to round to the nearest tenth. This problem would show how to do that. So A squared is going to be 2 squared plus my unknown B squared equals 4 squared. On my next line, I'm going to have 4 plus B squared equals 16. Now, I want to write a set of instructions, we'll call it a roadmap of what's being done to B. Well, there are two things being done to it. The first is we're squaring it, and the second thing that we're doing to it is we're adding 4. So to solve this, I want to do the reverse order of operations, and I want to subtract 4 first, and then I want to take the square root. So first I subtract 4 from both sides. And then I get B squared equals 12. And then in order to solve this, I want to take the square root of both sides. So B is going to equal, and I need the square root of 12. I'll cheat. Hey Siri, what is the square root of 12?
Square root of 12 is approximately 3.4641.
And I said to round to the nearest tenth. So this is going to be 3.5. So over here, this is 3.5 meters.